Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the starting material and product. The starting material is 1-hydroxyspy, 4.5, decane, which has a cyclopentane ring and a cyclohexane ring joined at a spirocarbon-bearing diol. The product is decalin, bicyclo, 4.4.0, decane, which consists of two fused 6-membered rings. Moving on to the next step. Generate the carbocation. Protonation of OH by H2SO4 converts it to a good leaving group, water. Loss of water gives a tertiary carbocation at the spirocarbon. At this point the carbon bears a positive charge and is the junction of the cyclopentane ring and the cyclohexane ring. Moving on to the next step. Determine what rearrangement converts a spiro 4.5 system into a fused bicyclo 4.4.0 decalin system. In the spirocarbocation, the spirocarbon is shared between a 5-membered ring, cyclopentane, 4 carbons plus spiro C, and a 6-membered ring, cyclohexane, 5 carbons plus spiro C. To obtain decalin, two fused 6-membered rings, one C to C bond of the cyclopentane ring must migrate, ring expansion of the 5-membered ring to a 6-membered ring. This is a 1,2 carbon shift where one of the C to C bonds of the cyclopentane ring migrates to the adjacent carbocation, expanding the 5-membered ring to a 6-membered ring while the positive charge moves to a new carbon. The resulting bicyclic carbocation, after deprotonation, yields decalin. And for the final step, identify which specific bond migrates. Bond C is the C to C bond of the cyclopentane ring on the upper side of the carbocation center. Migration of bond C means the carbon-carbon bond connecting the spirocarbon to the cyclopentane ring migrates so that the 5-membered ring expands to a 6-membered ring, creating the fused bicyclic, decalin, skeleton. This is a ring expansion via a 1,2 shift of a C to C bond of the cyclopentane portion. Eliminate other options. Bond A is a C to C bond of the cyclohexane ring. Its migration would not produce decalin but would give a different skeleton. Bond B is a CH bond. A hydride shift would only move the carbocation to an adjacent carbon without changing the ring sizes and would not yield decalin. Bond D is the other C to C bond of the cyclopentane ring on the lower side. Migration of D would lead to a different connectivity than decalin. Therefore, the correct answer is C. Therefore, the correct answer is option C.